just as a reminder, if you logged out yesterday, you will see the login page. If you did not log out yesterday, you'll see something different, and we'll get there in a second. But please sign in, username and password, and then you'll get to a point where you need to put in your authentication code. Again, this is if you logged out yesterday. You can put in your authentication code. Now, if you didn't log out yesterday, this is the page you'll get to. If you go to the link I put in the chat, you will already be logged in, and I'll just ask you if you want to launch your server. And so go ahead and click launch server. And we're doing this small server on demand. So you can go ahead and start that running. And then while this is running, Amanda can do some housekeeping. All right, it looks like I now have an operational Dask server. Is anybody else still waiting? Okay. Please let us know once your servers start up. Thank you. In the meantime, I'm going to review the last little bit that we got to at the end of the day yesterday before we move on. So, in the exercise yesterday, when adding a column, it appears that the data is automatically saved in the original file. Is that correct? Yes. And it's not a file per se, it's a variable that's holding the data at this point. But what you have correctly observed is that using this syntax, we're adding a column in place. So we are actually actively modifying the data held in the variable instead of just looking at printing out what it would look like if we did modify the variable. Yeah, exactly. Great point. Right. So the last thing that we did yesterday was we were talking about different things, different ways that you can alter data frames. And the last thing that we talked about was combining data frames. So this is something that we'll do when we're performing differential expression analysis. There's a step where we have a couple of different data frames with different types of data for a variety of reasons. We want to be able to combine them and have one big data frame. And so in this situation, the sort of example situation we've provided here, this is a simple enough join operation that we can use the R function cbind. There are other more complex ways of joining data frames together in R that we're not going to go over here. But when I say simple, what I mean is what we ended up doing here was we created a duplicate data frame, which means that both data frames have the same row names. So when we join together these data frames, cbind was able to just take both variables that have identical data frames and join them together on the rows. So the last thing that we did here was I had shown how we could run the cbind function, and between the parentheses we put in the variables holding the two data frames that we want to bind, separated by a comma. And that just prints out what it would look like if we did join these two data frames together. And so the last challenge we did was to actually create a variable called combined df that holds the combined data frame. And we did this by passing the result of the cbind function to the combined df variable via the assignment operator of this little arrow. All right. Are you guys still waiting on your Dask hubs to start up? Okay, great. All right. So because we have restarted our servers, we recall that yesterday and the day before, Amanda noted that any variables that we define in these notebooks are temporary and they only exist for the instance that we have running. Whenever that instance gets closed, those variables are lost. So right now, for example, if I were to run this cell, the combined DF assignment cell, I get an error telling me that the object myDF was not found, which means that R is not able to identify this variable. There is no such variable held in memory because it was lost. So what we need to do, I'm going to add two cells underneath, and please do this with me. I'm going to add two cells underneath the original C-bind cell where we're going to well, actually, what might be easier since we added all these columns and everything is actually let's just go back up to the very top of the notebook and just rerun every single cell until we get back down to the C-bind section. So scrolling back up to the top of the notebook, we can start with just the first cells where we had information and just press run, iterating through every single cell in the notebook. So what this is going to do is this will redefine all of our variables. So for example, I've just read back in the example.csv using the read CSV function and assigned it to myDF. So I now have the original myDF held in memory. So that's great. But remember, we did some alterations to the myDF variable. We added a couple of columns and we want those to be present as we move forward. All right, so I've now added the fourth column, I've added the fifth column. So now myDF holds 5 columns, 10 rows, and then I duplicate myDF by assigning all the data in myDF to a new variable called myDF2. We can print that out and show that it is indeed a duplicate. And then let's run the original cbind command and the combined DF assignment. So everyone should now be to the point where you can run this line. Combined DF is assigned to the output of cbind of myDF and myDF2. And this cell should run without any output. So there should be no output and no errors. So can I get a thumbs up from everyone once you are back to this point and you've been able to run this cell successfully? And please let me know in the chat if anybody is having any issues, is confused about what we just did, hasn't been able to sign on to the server. Or one other thing to double check is to make sure that the notebook, which should have still been open, is still running the correct kernel. So the R conda N GL4U-R. All right. Whenever I spam shift plus enter through all the commands, sometimes it unchecks. What do you mean unchecks the command? Feel free to unmute if it's easier.
Yeah, so it actually undoes the command, and the number that should appear when the command is successfully run has now disappeared, and that's the case for all of them.
It sounds like maybe your kernel restarted for some reason. So in that case, I would go back to the top and run through everything one more time and make sure that the numbers are appearing. I don't think it has anything to do with shift entering through all the commands. I think for some reason your kernel just had a glitch.
Okay. I started from the first one and I like the get WD one and I
Hmm.
shift entered and
Hmm.
once again the number disappeared and then whatever happened got undone.
Would you mind would you feel comfortable sharing your screen and showing me what you're dealing with?
Of course. Let's see.
Yeah, Ty, great point. So um the play icon has a shortcut which is shift enter. So if you select a cell and press shift and enter, it'll run that cell. So similar to just clicking on the play icon. Okay, so let's see what we're dealing with here.
Yeah, so right
Okay.
here I have I'm starting from the very top. This is the very first command.
So
And
I can
yes,
already see the issue. So and this is good. So everyone please note what's going on here. Top right, it says no kernel. So there's actually no kernel connected to this notebook. Yeah, exactly. So it's the R one, exactly. Click on that and select. So if anybody else also sees no kernel in the top right, you're going to have the same issue where you won't be able to run anything.
thank you. That's very helpful.
Yeah. So does anybody else see no kernel or really anything besides what we're showing the top right here, R conda and GL4U dash R?
Yes, I'm just running through everything and everything's working just perfectly. Thank you so
Beautiful.
much.
Yeah, absolutely.
Okay, perfect. Thank you. I'll unshare. How do I
Okay.
unshare? Oh, there we go. Okay.
I've just added in the chat so that we have it in writing, the correct kernel, what you should see in the top right. Okay. All right. So has anybody else had any issues getting to the point? Let me share my screen again, where you can has anybody else not been able to run the combined DF line um, without any errors or any output? And you should see a number in the brackets. All right, excellent. Okay, so um, now we have a challenge question, which I'm going to make into a poll. Use the next empty cell to check the dimensions of our new.
Lauren, excuse me. I have a
Yeah.
question. I don't know, how is it best that we have questions? I raised my hand, but I don't know if you're able to
Oh,
see it. In Zoom, you can see it really easily.
sorry, it's all the way over here in my peripheral, so
Yeah,
I
I
didn't
mean, I
notice.
hate
Thank
to
you
interrupt you.
for.
So
No, thank
I
you.
just have a question. So
Yeah.
when you use the dimensions, it automatically excludes the header.
Yes, that's a great question. Yeah,
Yeah. So
absolutely.
how does it know? Is that just the way it does? Is it the how does that?
Yeah.
Maybe this is more advanced at this point than
No,
we
no,
need to
no.
worry about.
No, no, it's not. Actually, this is a really good point. So this is another way to kind of illustrate what we did when we use the read.csv
Okay,
function.
went back to that. Okay.
So when we use the read.csv function, we specifically told R that the first line in the file is not data. Don't treat this as real data, treat this as column names. And the row, we also said don't treat the first column as
There it
real
is.
data,
Okay,
treat
so
it as
it's
an.
that one.
So
Okay.
that so then when we run dim, we're saying we want the dimensions of the actual data. Like that's the assumption when we
Okay.
run
So
dim.
it defaults to ignore.
Yeah. It
Okay.
the way so we could do a more in-depth study of what a data frame is in R.
Okay.
But so a data frame, the way I think of it, is it has multiple slots for different types of things.
Yeah.
It's a data structure where it has a slot for column names. It has a slot for row names, and these are called things like I think the column names are actually called variable names in R. But that's not necessarily important here. So that's one slot. The row names are one slot, and then the actual data is the data frame of the values. That's another slot. So there are at least three slots held in the
So,
data frame structure.
so the data frame, basically, you have a huge array of two-dimensional data. I'm
Mhm.
assuming it's two-dimensional. If it can be three, I'd be curious about that. I imagine it could be infinite, but I don't know. And then you just take anywhere in it, you just take a piece of it. It could be 2 by 2, it could be 5 by 8. And then you specify whether it has headers or not. Is that a way of looking? The data frame looks at a file, something that has to be in CSV format, or can it be
So
any format?
it has to be in tabular format,
Tabular
which is a
format,
kind of
okay.
vague way of saying it has to be separated. The columns have to be separated by something. And so like every
Okay.
row, the value in each row has to be separated by something. Ours happens to be separated by commas. It could be separated by tabs. It could be separated by anything you want.
Okay, got it.
Yeah.
Got it. And then the data frame is just like a virtual look that you play around with until you save it and make it what we would call like a
Fine.
spreadsheet again.
Yeah. So a data frame is a way of taking tabular
Yeah.
data and I mean
Mhm.
you can create a data frame in different ways. We've
Yes.
created one by reading it in from a file. So
Okay.
the read.csv function takes the data from a file and trans reads it into a data frame. And then in a minute we'll write it back out to a file.
Yeah.
But yeah, good question.
Beautiful. I'm getting the hang of it. The commands are a lot of them. It's going to take a while to remember them, but this is great the way you're teaching this. It makes so much sense to me, at least.
Thank you. I really appreciate the positive feedback. All right. So that was great to just unmute and shout out. Thank you. That's a great way of getting my attention, and I absolutely don't mind being interrupted. Um, so, as Elba pointed out, the dim function is only going to show us the dimensions of the actual data. So let's use the next cell to look at the dimensions of the combined data frame and use the dim function, which we used yesterday. So you can scroll back up and check on the syntax for using the dim function to look at the dimensions of a data frame. Um, and please go ahead and put your syntax into this cell, run it, and then look at the dimensions and let me know what the dimensions are in the poll. All right, I've opened the poll.
Lauren, I had that same issue where you can't type in the answer. At least I can't.
Oh,
I
um,
could this
try
time.
clicking where the answer is supposed to be. You might have a box that's kind of invisible, because I do see quite a few people are able to answer it. Any luck,
No,
Amanda?
but it might be because I'm still the host this time.
Oh, I don't even see you as someone who can answer the poll, Amanda.
Yeah, I think it's because I'm the host.
Okay.
Yeah, you're the host.
Well, that's okay. You're off the hook then. You don't have to check the dimensions. All right. I see several people still need to fill out the poll. So we want to use the function dim to check the dimensions of the combined DF data frame. So remember we used dim a little while ago. If I scroll back up here, dim was one of the ways we could assess what's going on in a data frame without actually printing it out. So remember, all you have to do is run the function with the name of the variable that holds your data frame passed in as the one argument. So if anybody is running into issues with this, not sure what to do, or is getting an error, feel free to put that into the poll as well. Still waiting on a couple more people to start their answers. Give you a few more seconds. All right, I'm gonna go ahead and close the poll. All right. Okay, so I think I did something wrong when I was setting up the poll because I can't actually see the results. So let's just run through this together and I'll just assume everyone got it right. So as I showed just a moment ago, in order to check the dimensions of a data frame using the dim function, we just write out the function, open close parentheses, and add one argument, which is the variable that holds the data frame that we're interested in. And we can just run this cell. And as you can see, the dimensions of our combined data frame are 10 by 10, which is what we would expect, 10 rows and 10 columns. And as Elba pointed out, the dim function automatically only takes into account the actual data values. It doesn't count the column names as a row or the row names as a column. All right. So now we have another question, which is, did cbind merge these data frames on the row dimension or the column dimension? And you can take a look if you are confused at the cbind documentation using the help function. So remember, we used the help function when we were first using the read.csv function. We use the help function to take a look at all of the different arguments that you can pass into a specific function. So remember, the help function is just like any other function. You type the name of the function, open close parentheses, and then the name of the function you're interested in getting help for. Okay. So I'm going to give you a few seconds to work on this and put this as a poll question. Please feel free to unmute or put a question in the chat if you're not sure you're getting an error. All right, I've just opened a poll. So the question is, did cbind merge these two data frames? So when we ran cbind up here, we passed in two different data frames. Did it merge them on the row dimension or the column dimension? And we can take a look at the cbind documentation using the help function if you're not sure. All right. I still see several people who haven't yet had a chance to answer. If you're not sure, feel free to put that in the poll. If you have a question, feel free to put that in the chat or on mute. All right. Great. Thank you, everyone. I'm going to go ahead and close the poll now. All right. Let's see here. All right. Okay. So a few different answers. So this is a little bit of a tricky question because it gets at how R thinks about data frames and dimensions. Okay. So let's start off just by going with the hint here and looking at the cbind documentation using the help function. So help is just like any other function. Type the name of the function in open close parentheses, and then the name of the function that you want to get help for. So that's cbind. This in the chat here. And we can run this and take a look. Okay, so the title of this function is we can combine our objects by rows or columns. And so this is not just specific to data frames. You can do it with matrices or vectors, which we're not going to do, but just good to know. And you'll note here that there are two different functions listed. There's cbind and there's rbind. Yeah, exactly. Help is the R version of dash dash help from Unix. That's right. And they make a point here by noting that you can combine by columns with an C italicized or rows, R italicized. So the under details, they let us know. So these two functions are generic for multiple methods, but they work for data frames. And see if there's anything else that I wanted to highlight here. There are a lot of details. You can feel free to read up on your own time. And this is just to note here that cbind and rbind respect the column and row names, which we assigned when we read in the original data frame, and we assigned column and row names. So overall, what we can take away from this help menu is cbind. The C stands for columns and the R stands for rows. So that's not said explicitly here, but it's kind of hinted at in the description here. So cbind is a method that's designed to combine an object by columns, and rbind is an object, a function that's designed to combine objects by rows. So if we scroll back up and look at how we use cbind in the first place, the way R thinks about combining these two objects is whether it's combining columns together or whether it would be stacking rows on top of each other. And so because we used cbind, it combined columns together into one big data frame. So the answer to this question then is R thinks about cbind as merging these data frames on the column dimension. So I do see a couple of answers that say, well, cbind appears to have merged along rows. And so this is just kind of a technical distinction demonstrating that R thinks that it has combined on columns. To us, it looks like, we've combined on rows, but to R, that would actually mean taking two data frames and stacking them on top of each other. So this is kind of a technical distinction. Let me know if that was confusing to anyone. But so if we had used rbind, it would have tried to take the two data frames and stack them on top of each other, row-wise.
So I have a question. This is
Yeah.
Elba again. This is great. This is the definition of what dividing by columns or rows. So it establishes the frame of reference, so to speak. What if one of those files had a different number of rows? What does it, when it merges, does it default to zeros or does it leave it empty? What happens when these happen to be two data frames of the same dimensions? So
Yeah.
either way, they would have stacked into an orderly data frame. But
Yeah,
what
this
if
is a
they're
great
unequal?
Great
What happens?
question. So in this case, so cbind and rbind are simple and kind of rigid functions. That means that if you want to combine on the column dimension, there have to be the same number of rows. There are other more flexible, complex functions in R that can take data frames of different dimensions and add NAs or zeros as options. We're not going to get into that right now, but for this case, the reason that these data frames were defined to have these exact dimensions was so that we could run cbind without an error. And that is also what we're going to do later on when we're doing analysis. We just make sure that the data frames we need to combine have the same dimensions.
Thank you.
And so we could also just demonstrate really quickly what would happen if we ran rbind. So we just ran cbind. I showed it, R thinks it's combining on columns. So if we were to run rbind on our two data frames, what would happen here is, like I keep demonstrating with my hands, R took these two data frames and stacked them on top of each other. One thing that you will notice here, though, is unlike, so originally with cbind, we got a big data frame which has duplicate column names. R doesn't mind having duplicate column names, but it absolutely does mind having duplicate row names. So it has fixed it so that we don't have duplicate row names here.
How did it pick the numbers? I mean, it didn't go to 12.
I think it's added one to the end of everything. It just added one to the end of everything. Yeah. So if we
Interesting.
had like if these were the names of genes, this would be a real problem because we would now have names of genes with one added to the end, which is not a real name. So that you have to be very, very cognizant of the way that you're merging data frames together and these little magic things that R does that may or may not make your life easier. Okay. Please continue asking questions. These are great questions, and I will keep going until I get another question. So we were talking about earlier how we read in data from a file into a data frame. And we can also write the data frame back out to a file to save it, because as we saw this morning, the data held in that variable completely disappears after you kill your instance. So in order to save it, we want to write it out to a file because that's not going to go away. So similarly to reading in data in R, this is going to depend on the file type to which you want to export the data. And R has several built-in functions for exporting common file types. We can write out to a text file, a CSV file, a TSV file, and there are others, but we're going to focus today on exporting the data as a CSV file because that's how we read it in. So we're going to write it back out now that we've made some alterations to it. So we're going to use the nicely named write.csv function to write back out to a file. And here, this is really simple. The only arguments that we need to pass to the write.csv function are the name, the variable that holds the data frame we want to write out, and the file name we want to write to. So I've pre-populated this cell with the function write.csv, passed in the argument for the name of the data frame we're writing out, and the name of the file that we'd like to write to. So you'll notice the variable I've passed in not as a string because it's a variable. If I put quotes around it, R wouldn't treat it as a variable. We need R to treat it as a variable and access the data that's held in that variable. But the name of the file I want to write to is a string, so that R will just interpret that as the name of the file. It's just a string of letters. So let's all go ahead and write this, run this cell, which will write our combined data frame out to a file called combinedf.csv. When I ran this cell, I immediately saw on the left-hand side a file pop up called combinedf.csv, last modified seconds ago because I just wrote it out. So did anybody have an issue running this cell? Anybody run into an error? Right. So in the next cell, we can confirm, if we didn't have this nice handy file directory, we could run the list, a new function I don't think we've used before called list.files. We don't have to necessarily pass any arguments to this function because we're listing the files of our current working directory. If we were trying to list files in another directory, we would have to pass in the path here, but we're just doing current working directory, so we can run list.files without any arguments. So if we run this cell, we should see combinedf.csv as one of the files here. So if anyone doesn't see that, please holler, just let me know. Hopefully everyone is able to see that file. And then finally, the last challenge we have before we get to visualizations is let's export the mydf2 data frame as a CSV file called mydf2.csv. So you can use the same syntax where you pass in the data frame and the file to which you want to write. But this time, make sure you specify your home directory as the path you want to write your file to. And as a hint, you can use the home dir variable that you created previously. So I'm just going to remind you of some syntax that we learned when we were reading in files. So remember, we defined a home dir variable. I've just added a couple of cells here and I'm typing in home dir just to remind us that we have a variable that holds the path to our home directory. That's where we want to write out. Now remember, when we were reading files in, I pointed out this handy function that can take the variable that holds a path and the name of a file and stitch both of these together to create a complete path. So this is the file.path function. And this function creates a full path from a variable, for example, and the name of file. So going back down to where we're writing out our files, part of this hint says, write out your mydf2 data frame, write it out to a specific file, but pretend you're in a different directory and you have to specify the directory where you want to write. So specify your home directory using the home dir variable that you created previously. And so just as a reminder, you can use this file.path function to create a full path. And so here, instead of example.csv, you could pass in mydf2.csv as the file where you want to write. And just recall, scrolling back up one more time to when we were reading files in, remember I pointed out that you can actually pass the entire output from your file.path function. You can use that function as the first argument to read.csv, and as a hint, you can do the same thing for write.csv. Okay. So this is a little bit complex. This is kind of the same thing we were doing yesterday where we're stacking multiple shortcuts on top of each other. So I'm going to give you a few minutes to try to figure out some syntax to use this cell to export your MyDF2 data frame using this write.csv function. But instead of passing just the name of the file, specify the home directory as the path you want to write your file to using the home dir variable we created previously. And then go ahead and list all the files in your home directory. You can use list.files for that and see if you successfully exported the file. So I'm going to start a poll for this and give you a few minutes to work on this syntax. Please feel free to ask a question if anything is not clear. All right, I've just started a poll here. So what we're trying to do is alter the syntax that we've already used, our write.csv syntax, change it so you're writing out your MyDF2 data frame, write it out to a file called mydf2.csv, but add something here using the file.path function so that you can specify your home directory as the path you're writing out to and use the home dir variable. So this is using lots of different types of syntax that we've used, we've learned. So this is a tough one, and I see quite a few people might be still working on it. If you're not sure where to start, you can refer back to this original syntax that we used to write out combined DF. You start there, and just first of all, start by altering it to export the MyDF2 data frame. If you're not sure or you have a question, feel free to put that into the poll as well. Or if you tried something and it didn't work, you can put the error into the poll just kind of to let me know where you're at so I can help out. All right, I'll give you guys just a couple more seconds here. All right, in the interest of time, I'm gonna close this poem. This is a pretty tough question, so we'll go over it slowly together. Okay, let's see here. All righty. So let's see here. Right. Great. All right. I am seeing some correct answers and some close to correct answers. So let's go through this together. And for those of you who weren't able to answer this question, please, if my explanation doesn't make sense, or if you're not quite sure how I arrived here, please feel free to shout out and let me know something wasn't clear, and we can review again, because this is not trivial. So let's just take this one step at a time. So as I mentioned, you can just start off with the original syntax that we used to write out our combined data frame and just alter it so that instead you're exporting your MyDF2 data frame. So one thing that I'm noticing in the answers is it's really important to remember that the order in which you pass in these arguments is important. So when we used write CSV the first time, notice we passed in the data frame we want to write out first and the name of the file second. So we have to keep that same order here. And so I'm going to start out with the variable that holds my data frame, my df2, and then the name of the file I want to write out, and that's my df2.csv. But remember, we're pretending that we have to write this into another directory. We're pretending we're not in our home directory. We need to write into our home directory. And we don't want to specify, we don't have to type out the whole path to our home directory. We want to just use this little variable that we use that refers to the path to the home directory. So how can we do that? Well, we know that we have this file.path function, which will create an entire path to a file by just stitching together the path held in the home dir variable and the name of our file that we're interested in. So let me put this syntax into the chat. You guys can all run this on your end, and it will show you an entire path to your home directory to the new file that we want to write out to, okay? So instead of specifying just the name of the file, we need to specify that full path to the file. And we can do that by passing in this little bit of syntax using the file.path function in place of just simply the name of the file. So now, as you can see, I'm still maintaining the order in the write.csv function. The first thing I'm passing in is the variable holding the data frame. And the second thing I'm passing in is the path to the file. So originally when we wrote write.csv and we wrote out combined df.csv, we didn't have to specify the full path because we're in our working directory, we just write out that same directory. So there's a kind of an invisible path here. There's an assumed path. R interprets this as right to the working directory, so it takes what is our current working directory and it just kind of invisibly adds that path on so that it knows exactly where to write the file to. So here it's the same thing, except the path is not invisible. We are specifying the path by providing the full path through the file.path function, which stitches together home dir and and the name of the file we're writing to. So let me put this syntax into the chat. 55 is assigning my home dir to my df2. So good question. If you look at the output of this cell, so the 55 is the number next to the cell. So if you look at this cell where I've run the file.path function and I've passed in 2 arguments to this function, home dir, which you can look up above. Home dir is just the path of my home directory. And the second argument is the name of a file as a string. If you look at the output of this cell, you can see what's the file.path function doing? Well, it has stitched together the path to the home directory and the name of the file. And it's printing out, what does that path look like? It's /home/jovian/mydf2.csv. So you can actually see the output of this syntax right here to see what it actually is doing. Yeah, so to speak. Yeah, so it's saying that this file belongs in this home dir folder. Yeah, that's a good way to think about it. So let's go ahead and run this syntax that I just put into the chat, and nothing should happen. We shouldn't get any output or any errors because we're just writing a file out. And then in the next cell, we can check that we successfully wrote out mydf2 to a file called mydf2.csv by saying list files. But in this case, let's make sure that we're actually listing the files of the place where we wrote out. So again, pretending we're not in our home directory, we want to check what's going on in our home directory. Let's say list.files, and this time we're going to pass in an argument. We're going to pass in home dir. So we're saying, please list the files in this specific directory. We can run that, and we can see that I do in fact have a new file called mydf2.csv. So let's see. Write CSV. Dir CSV. This function I used, and it appeared to write out the correct file and place it in the home directory. So Mark, what happened here is when you ran this, you wrote out something to a file called mydf2.csv. So you will get, because you have the right order, you have the thing you want to write out, and then you have the name of the file. But the thing that you wrote into that mydf2.csv, I believe all you will have written out is what's held in the home dir variable. So same as when we're writing out mydf2, it's writing out the data that's held in the mydf2 variable, which is our data frame. Well, what you will have written out is the name of, what you will have written out is the actual path, this string, home/home/Jovian. That's all that's going to be in the mydf2.csv file. Misunderstood. Let me try again. Yeah, nickname for specific file path. Yep. We assigned home/Jovian to home dir, so it's easier to call back that file path. Yep. File path just simply overwrites that sentence. So file path isn't overwriting. File.path isn't overwriting anything. It's squishing together two things. So let me just try typing this out. So what file.path is doing is taking what's held in home dir. So file.path is literally just taking 2 strings of letters and smashing them together with a slash between them. So it's saying, okay, home dir, what's home dir? It's home/Jovian. Okay, great. What's the second part of what's my second argument here? It's my df2.csv. Okay, great. I have this half. I have the second half. What do I put between them? A forward slash. So all it's doing is creating a third string that the computer will then interpret as a path to a file name, because we need it to interpret that as a path to a file name. So mydf2.csv does not exist at that point. It exists, it will exist once we write it out, but we have to tell the computer where do we want to write it out to, and then what's the name of that CSV file? Well, it's mydf2.csv. So it's a convenient way of writing out an entire path to a file using using a string that is the first part of path and a string that is the desired name of the file. Yeah, so if you were to assign that to a new variable, right? So like what you're saying, new home dir, let's try that. That's a good question. So if we were to try that, yeah, the number 55 was not necessary to do. I was doing that to make a point as an illustration. All number 55 was doing was printing something out. It didn't actually effect any change. No new variables were created, no new files were created. Yeah, exactly. So let's try this example where we're actually assigning the output of file.path to a variable. So in this case, something is happening. We are creating a new variable. If we were to do this, and then remember, I can add a new line to this cell where I print out what's held in that variable. Let's check and see what happens. If I do that, it prints out the output of the file.path function. That's now held in new home dir. Okay, so you're right. So this is a shortcut where I am kind of nesting functions inside of each other. I've nested the output of the file.path. Yeah, exactly. So here, this is exactly the same syntax here. Since I've assigned the output of file.path to a variable new home dir, I could do this. Now, keep in mind, so you named this variable new home dir, but what the variable is holding is the path to a file inside of a directory. Now, the file is imaginary at the point that you just create the path to it. We haven't written anything to that file, but for our convenience, it's nice to have a path specified to that file, because later on we'll write something to a file with that name at that path. But so all you're doing is creating a variable that literally just holds a string. A string is just a linear combination of characters, which because it is formatted a specific way, it's a correct path separated by forward slashes, R can interpret this string as the path to a file. It also has a .csv at the end, so and then we pass it into a function called write.csv. So all those things together means R can interpret it as the place to which we want to write the data held in mydf2. Exactly. So the whole point of doing this is so that you do not have to type out an entire path to a location and a file name every single time. Imagine if we had 20 files that we wanted to all write out to home dir. We don't have to type out like the full path every single time. So we've just kind of gone in a couple of different places, different ways of thinking about this. Everyone who's been quiet, are you lost? Can I go back and go over something here to help bring everyone onto the same page, or is everyone cycling all together here? Okay, I see it. One thumbs up. That's great. All good. Yeah, please feel free to unmute. No. It's really not frustrating. when I was in grad school, I had never used R before. And I did not understand that. I had never really coded before because I came from wet lab. I did not understand that you have to read the information in a file into a data structure in R to do something with it. I was like skipping that step and trying to pass in just the file name to like some program to do something with it. That was frustrating. This is not frustrating. This is how it goes when you are learning how to code, and this is not something that you've done before. So I'm more than happy to continue going over this. These are complex concepts and very abstract as well. Oh, I have a lot of horror stories about R, so we won't get into that though. R is very useful. Okay, but in all seriousness, does anybody have any questions, or is this not clear to anybody? I really want to make sure that you get this before we move on to the next part.
So I have one final question, but I suspect the answer may be in another section. I'm thinking, I'm reviewing as you're talking the commands, and we took the data frame and we subtracted and added. Can we multiply two data frames? Can we, or is that matrix manipulation? Is that a more complicated language?
I think that you can. Let's
We can
see
just
what
do-
happens.
Yeah.
Let's see. And Mike, feel free to stop me if I'm about to explode R. Okay, nope, it worked. So I just multiplied. I used the asterisk because I know in R that's, and probably other languages, that's how you do multiplication. So I just multiplied my DF to by a MyDF, and oh, I could check this with the calculator, but it looks as if all of the values have been multiplied by their same index in the other matrix. So
Beautiful. I love it.
yeah, yeah, exactly. Thank you, Mike. Yeah, exactly. It's fun to help
And
people
divide is just
understand
the
stuff.
slash. So you could divide my DFA. What happens if there's a zero? Let's try.
That's
There
right.
are zeros.
So that's where you
Oh.
get
Ah.
not
Oh yeah,
a
they are all
number,
one. And then it what's NaN?
not a number.
Not a number.
So
Cool.
yeah, that's like
Cool.
when you try to divide by zero. Yeah, yeah, yeah. Pretty cool. Great question. Okay, we can absolutely come back to this. Like I said, I really want to make sure that everyone's understanding this. I know that this is complex for like, especially this is like the second day that you've ever used R. This is why we call this a boot camp, you know? So if you're kind of mulling this over and you realize that you have a question, please shout out. We can always come back, no problem. In the meantime, I am going to move on to the visualization portion for now. So the reason that we are going over visualizations in this intro notebook is because at the end, the very end of all of the analysis of the RNA sequencing data, we're going to do some visualization using the gene expression data and different genes and kind of showing how gene expression patterns change throughout samples. So here we're doing something much more simple just to kind of get our feet wet with visualizations in R. We're just going to start off with a basic built-in function that R has for many common plot types called plot. And that's just a function just like all the other functions we've used. You have the name of the function in open close parentheses. So at its most basic, there are other things you can do with plot, but at its most basic, the function call is plot with two parameters, x comma y, where x and y are numeric vectors containing the x coordinates and the y coordinates for the plot. So we can go ahead and call plot, see what it looks like, if we use the following parameters where X is the values from mydf2 column 1 and Y is the values from mydf2 column 4. I want to note I just did a bunch of math up here. None of this was saved into memory because I didn't overwrite any of these variables or reassign them. So this is just what it would look like if I did this multiplication, what it would look like if I did this division. So my DF2 still looks like it does back up here. It's just a duplicate of my DF. All right, so remember that we used the bracket syntax to slice out one column from my DF2 or any data frame. But recall that what this does is it produces a tiny little data frame. So you still have your row names, you still have your column names. That's not a vector of numbers, and that's going to confuse the plot function because the plot function is not expecting row names and column names. It's just expecting a list of numbers that it can use as X coordinates or a list to use as Y coordinates. So we need to use some different syntax to just access the data values from the column that we're interested in. So there's syntax that uses the $sign. That $sign is a special character in R. And it, if you pass in the name of a data frame, the $sign, and then the name of a specific column, then that will access just the values from this column as a vector of numbers. As a note, yes, so the $sign specifies the column title. And let's go ahead and use this syntax. So let's actually, I'm going to add, just to illustrate something, I'm going to add a cell here and just show what it looks like if we were to run this syntax. So go ahead and everyone with me, please add a new cell and run this syntax where we're grabbing just the values held in the column 1 of my DF2 using a $sign. As you can see, we get a vector of numbers. This is how R prints out lists or vectors, is the items in the vector separated by little dots. So recall that in order to call the plot function, you pass in the vector that you want to plot along the x-axis and the vector for the y-axis. So if we want to use the values from IDF column 1 as the x vector and the values from IDF column 4 as the y vector, we can employ this type of syntax and pass this item into the plot function and then do the same thing for column 4, because as you can see, this syntax just corresponds to a vector, so we can pass this straight into the plot function, right? So I'm going to give you a couple of minutes to add in your X and Y vectors to this plot function call and let me know the syntax that you use, and then I'll do it and we can all look at the plot together. Okay, I've opened a poll, so please go ahead and put the syntax that you come up with to the poll. Feel free to ask questions if you're not sure what's going on. All right, great. That was fast. Thank you, everyone. Okay, great. Let's see. Nice. Nice. Okay, great. Great job, everyone. So, all right. So let's do this together. So the syntax is plot x comma y. So what did we want to use as x? We wanted to use the values from IDF2 column 1. And so we can just pass that right in as the first argument. Again, this is order dependent, the way we're doing it. So it's important to pass in our x values first, then separated by a comma, pass in the y values. What did we want to use for y? We wanted to use the values from IDF2 column 4. So put that here. You have 2 column 4. All right. So put this syntax into the chat, and we can go ahead and run this cell, and we get a plot where the values from column 1 are on the x-axis, and the values from column 4 are on the y-axis. Any questions about how we did this?
I have a quick question.
Yeah.
What happens if you only feed it one parameter? So if you don't have the column 4 there and you only print column 1, what will happen?
Let's see here.
It uses the row.
Yeah, nice. Okay, so what's happened here is it used the argument we passed in as the y values, and index is another word for row in R and Python. So it used the index for each value as the x-axis. So the first row was 1. That value is on the y-axis. The second row was, yep, the second row was 4, and so on and so forth. Does that make sense? The 10th row is 0.
Yes, thank you. That makes a lot of
Yeah.
sense to me.
Okay,
So this
great.
is interesting. So look at where the 0 is on 10. And I'm looking at the first parameter. So on this one, it starts at what I think is 1. But look above. If you go above to the figure above, there's a little dot at 10.
So here,
That guy.
yeah, so what we're doing is we're plotting column 1 against column 4. So
So that's 10 is the first number? No?
so
10.
column
Okay,
4
yeah,
is on the
okay.
y-axis,
10.
and
Okay.
so 10 corresponds with 0. Do you see? So we're plotting the values for column 4 on the y-axis against the columns for 1 on the x-axis. So by the
Okay,
time we
it's
get to
the
the end
opposite of
here,
how I think about it. Okay.
okay. Anybody else having questions about this? Good. Okay. Okay, so this is a great plot, but we can actually make it more interesting and visually appealing. Let's take a look at the parameters for plot by using the help function. So go ahead and run this cell. So plot tells us this is the default scatter plot function, and there are a lot of different arguments. So we already know about x and y, and we did that already. Now there are 2 arguments here that I'm going to ask you to use in the next challenge. So I'm going to draw your attention to those. Okay, but there are other ones here that you can feel free to play around with. So the first one is type. So you can set type equal to a 1-character string giving the type of plot desired for things like P is for points, L is for lines, B for both points and lines, so on and so forth. You can read through the rest of the arguments at your leisure, things like labels for the X and Y axis, but I want to point out one more graphical parameter, which is COL for color. And so multiple colors can be specified, or you can just specify one. And again, you're going to specify this by setting col equal to the name of, it can get more complicated than that, but you can set it equal to the name of a color that you're interested in. So with that in mind, having looked at the help menu, and you can refer back to it, let's recreate the plot above, the one where we passed in both X and Y values, but pass different values to type and col. So in particular, create a plot that has both points and lines, so that comes from the type parameter, and that is colored purple. So one thing one thing to note is the syntax. I'll just give you a hint here that as you're creating your new plot, you're going to add in 2 more parameters. Recall that you need to separate parameters by commas in a function. And whereas here we were just able to set X and Y as what's called positional arguments, so X comes first, Y comes after that. Here, you're going to need to specify that you're setting something for type and something for col. So I'll give you a hint that the way you're going to want to do that is type equals the thing you want to set type equal to, or col equals the thing you want to set col equal to. Okay? So I'll give you a few minutes to work on this syntax. And I've opened a poll, so feel free to share your syntax once you have it available. And once you run it and so it's working successfully, feel free to ask a question if you're stuck, if you're not sure where to begin. So recall that you can just start with the syntax that we already established, where you're plotting the X and Y values as positional arguments. And then you want to add into this syntax 2 more arguments. You want to add in type, set that equal to something that will allow you to create a plot with both points and lines. And then you want to add in a 4th argument, again, separated by commas, where you're setting col equal to something that will allow you to color this plot purple. All right, so in the interest of respecting the breaks, I am going to close the poll now, and we will go over the answers, the answer to this question and explanation, answer any questions after the break. So thank you so much, everyone. Please be back by 9:50 Pacific time.